Hey guys, find the domain of these three functions. Couple things to remember. Number one, you can't have a negative number underneath of a square root. Number two, you can't have 0 on the bottom of a fraction. And three, you can't take the log or ln of a negative number or 0. So the number you take the log of has to be positive. Let's see how this affects the domain of each function. In question A, we have a square root on the bottom. Now, what's underneath the square root isn't allowed to be negative, because you can't take the square root of a negative. And what's on the bottom can't be 0. So what that leaves us with is that what we're taking the square root of has to be bigger than 0. If it is 0, then we've got 0 on the bottom of the fraction, and that's no good. If it's negative, you just can't take the square root. So the question is, how does this affect the domain? Well, treat this like a regular equation. Move the 3 to the other side. 2x is greater than negative 3. And then divide both sides by 2. Now on a test, if you end up dividing both sides or multiplying both sides by a negative number, you have to switch the direction of this sign. That's not the issue here. We're dividing by positive 2. So x has to be greater than negative 3/2, and that's the domain of this function. Let's try this again in B. B, though, only says tan x. What's special about tan x? Well, tan is sine divided by cos. So all of a sudden, we're limited by the fact that cos is not allowed to be 0. When is cos 0? Well, according to the graph, which I hope you have memorized, cos is 0 at pi over 2 and 3 pi over 2, at least in radians. That's 90 degrees and 270 degrees. At the very least on the interval from 0 to 360. These repeat. It's actually all odd numbers of pi, if you want to write it that way. It's 2k plus 1 pi. See, these are all the odd numbers, at least when k is an integer. But it should suffice to say that it can't be pi over 2 or 3 pi over 2. Again, the denominator can't be 0. Lastly, we have to figure the domain of this ln. I call it the ln. I don't care what you call it. You're not allowed to take the ln of 0 or a negative number. Put another way, the thing that you take the ln of has to be greater than 0. Now there are a couple ways you can solve this. You can solve it graphically. X squared minus 4 appears something like this. It has x-intercepts at 2 and negative 2. And clearly this function, x squared minus 4, is greater than 0 when x is less than negative 2 or when it's greater than positive 2. See, on the left side of negative 2 and on the right side of 2. Now you can also get that algebraically from this function here. What you'll notice is that we have x squared must be greater than 4 itself. What numbers can you square that give you numbers bigger than 4? Well, any number bigger than 2 will give you that, but also any number less than negative 2. Put another way, x squared is greater than 4 means that x, or the absolute value of x, has to be greater than 2. These are all interchangeable here. Anyways, that's the domain of the function. Now, the last thing I want to point out is that this was the only question on the actual midterm. I just threw in the others as practice for you. This can also be written as negative 3 over 2 with a round bracket and positive infinity with another round bracket. The round brackets mean it's not exactly equal to that value. It's not x is less than or x is greater than or equal to negative 3/2. It's just x is greater than 3/2. That's what this round bracket means. The plus infinity here represents the fact that it's everything bigger than negative 3/2. And infinities always get round brackets because you can never actually equal infinity. It's another way to write the domain. And if you need more practice with that, feel free to ask a friend. I'll wish you only the best on your own questions.